Welcome to our program, Astronomy for Everyone. This month's episode marks a milestone in our program. This is our 25th episode, taking us into our third year on the air. We hope you've enjoyed all of the programs we've brought to you up to this point, and we look forward to doing it as well in the future. Our program for you this evening is on comets, and with me here in the studio is Steve Whitty. Steve, good to see you again.
Oh, thanks, Don.
Now, comets, what are they?
So comets are objects that orbit the sun. They typically have a big tail. You may have seen pictures of comets that have a big tail. So what generates the tail is that the comets have what we call volatiles. They're usually ices that in the vacuum of space, when the comet gets close to the sun, they turn from a solid, typically directly to a gas, and when they do that, they push out dust and other particles, little gravel bits, whatever, and this forms a sort of a cloud. And then solar pressure, the solar wind and so on, pushes this material away from the sun. So the comet has a tail that essentially faces away from the sun at all times through the orbit.
All right, very interesting. I think one of the most well-known comets out there is Halley's Comet. What have you got to tell us about that?
Yeah, Halley's Comet wasn't discovered by Halley. What Halley did was, it was kind of interesting. He was the first to study the historical record of comets. So this is around 1600, maybe 1650. He studied the historic record, which included comet sightings by the Chinese and the Arabs, and he saw that there seemed to be a bright comet that seemed to come back again and again, roughly every 76 years. And in addition, he plotted sort of a partial orbit of where he thought the comet was going around the sun for the very first time, and he suggested that Halley's Comet was in fact a periodic comet, that these weren't different comets that were being seen every 76 years, that it was in fact the same body, and he predicted its return. Now, he didn't live to see the return of Halley's Comet, so in his write-up he said, perhaps you could do me the honor of naming this comet after me if it in fact does come back.
And in fact it did.
And in fact it has come back numerous times, so we call it Comet Halley, technically. Now, we saw it in the 80s. I personally didn't see it because, not because I couldn't have, but because the comet hung around pretty much on the other side of the sun from Earth. It was a poor apparition. I mean, you could see it, but it was difficult to see, and I didn't get a chance to see it when it did.
Now, we've sent out a couple of different probes to take a look at Halley's. One was sent by the Russians and the other by Italy.
That's right. So the Russians had a series of probes called the Vega series, and these primarily were designed to go to Venus. And in fact, a Vega probe dropped an atmospheric descender, into a balloon, in fact, into the Venusian atmosphere, and then went on to visit Comet Halley. And it was the first spacecraft to arrive and get any kind of pictures at all, any kind of data at all, close-up data of the comet. A little bit later, and I'm talking, a few months later, the Italian spacecraft Giotto made a very close pass to Comet Halley, and this close pass got the best pictures of the comet's core, the nucleus of the comet. And now, having done that, it actually also took the most damage from the debris that was shed by the comet. So it took a real beating. Some instruments were lost, for example, but it got the best data.
Okay, and here we have this image up on the screen. What do we have here, Steve?
Yeah, this is the nucleus of of Comet Halley. So this isn't the whole, core. This is just the core. It doesn't have the whole coma. It doesn't show any of the tail really. And what you're seeing on the top there, the bright sections, those are jets of material that are coming off of the core of the comet.
The volatiles you talked about
The
earlier.
volatiles that I've talked about. So the whole comet, it's potato-shaped. It's not round. It's maybe 15 miles across, and so the object itself is fairly small. The reason why they're so bright in the sky and you see them is that the tail can stretch for millions of miles. And so you have millions of miles of material that can reflect light from the sun, and so they're quite visible.
Now, we've had a number of other comets that we visited with space probes, Temple 1, for example.
That's right, Temple 1. So Temple 1 is kind of an interesting comet because we actually had a spacecraft not just fly by it, but actually drop an impactor into the comet.
And I think we have Temple 1 up here on the
We
screen.
have Temple 1 up here on the screen, and at the bottom of the screen, toward the bottom, there's a fairly prominent crater. It's not that big. It's not as huge as that one on the top, but toward the bottom you see a fairly prominent crater, and there's another crater right next to it that's harder to spot. And the impactor went between these two little craters at the bottom of the screen. And so the impactor was basically a big hunk of copper. Now it had its own spacecraft associated with it. So it had cameras. It was looking at the comet as it was impacting, and it guided itself to the comet. Anyway, the most of the mass of this impactor was made of copper because copper was not expected to be found in the comet itself.
So they could tell the difference between the material of the impactor and the material that was original to the comet.
Absolutely. And so the mother craft stayed away at a distance, and it took these images, and it got the evolution of the impact. The debris came up, etc. One of the sort of disappointing things that happened was that there was more dust and debris that was ejected from this crater, and so they couldn't actually see the crater itself. The size of the crater would tell them very much how strong the surface material of the comet is, and other interesting structural bits of.
They could
of
tell
the
whether it was
comet.
more solid or just a loose ball of aggregate.
That's right, exactly. And but because there was all of this dust, they couldn't actually see the crater, and the mother craft whizzed by the comet before the dust settled. Data from actually X-ray data from the Swift Space Telescope showed that the plume lasted for 13 days, and it was at its most intense at about 5 days after the impact. So this event was actually quite significant. It took quite a while for it to sort of unfold. Up on the screen now is the impact position. So on the left we have an image from deep impact from the mothership. Just a zoom in of these two craters that were at the bottom of that other image. And on the right, we have re-imaging of the same location by another spacecraft about 5 or 6 years later. And the yellow arrows show the actual crater. And so we know, in fact, that the crater was about 150 meters in diameter. So you can think of it as 150 yards. And that tells us quite a bit about the structure of this comet.
Okay, what about another comet that was visited? We would say in English wild, but in German it's wild.
That's right. So it was named after the German astronomer who discovered it, and in German a W is pronounced like a V. So Wild 2, this was his second discovery, and Wild 2 was imaged up close by another spacecraft, the Stardust spacecraft. Now, Stardust was launched, and it visited Wild 2 first, but it also had a sample return sort of a wand. It has this really weird material called aerogel, and it flew through the tail of Comet Wilt 2, and it returned a capsule to Earth with this cometary material in it. It also collected some dust, which is believed to be not of the solar system. So by returning this material to Earth, you get to use every instrument that has ever been, not just your best microscopes, but every instrument you can think of, and things that even haven't been invented yet. If you wait long enough, something will be invented, and you can study this material with it later. So the Stardust mission brought material home, and then it went on to. So in the image above, we actually see dust trails in this aerogel. The material enters the aerogel from the left in a little bit, and then as it moves to the right, it's expanding a bigger and bigger track in this material. So the material was then sliced into little slices and imaged with a microscope. The images were then, it was an awful lot of data to analyze and to even find these tracks. And so what they did was they enlisted the help of just anyone with an internet connection, and they put these images up on the internet, and you could sign up and you could say, okay, I'm on this image, and I've discovered, or I see something that looks suspiciously like a track. So you have a little bit of training, 5 or 10 minutes, and then you do this. And then multiple people got to look at the same image, and if multiple people see that, oh, there's a track there, then that's something that the scientists can then follow up with.
Now for Comet Hartley 2, this was also visited by Deep Impact as well?
Yeah, so Hartley 2 was, so once you put a spacecraft into, you launch it, you spent most of your money, because getting a spacecraft even into low Earth orbit is very, very expensive. But once it's out and wandering around the solar system, well, it's there, and why not use it as much as you can? So after Deep Impact went to Temple 1, they decided that they would go on and visit another comet as a continuing mission, the mothership.
Okay.
And so they actually had targeted a different comet. Oh, geez. It's...
was that Bothan?
Yeah, Botha, right.
Okay.
So they had proposed that they would retarget the comet to the spacecraft to visit Botha, but as they were approaching the Earth for a gravity assist to change the orbit of the spacecraft to make it to Botha, astronomers could no longer find Botha. It had become too dim, and what was assumed is that the comet had broken up and the pieces were too small to see. So what they decided to do was, at the last minute, right, was they decided to change the orbit to visit Hartley 2. And so for very little money, you get essentially 2 missions for one. You get Deep Impact to visit Temple 1, and then you get Hartley 2 as a bonus. And Hartley 2 was visited last fall. That's like November 2010, and it was great. It was a raging success. We got great images of this comet and great data from up close and personal.